Alrighty, we got a test coming up pretty soon here on 2.5. So let's work on some practice problems to get ready for that test. Here, number one, of course we got to know our parent functions pretty well. And the first one here is the absolute value of x. So that's just going to make, of course, everything positive. So as we plug in these positive x values, 1 we get a 1, 2 we get a 2, 3 we get a 3. Same thing on the negative side. The absolute value of negative 1 is 1. The absolute value of negative 2 is 2, and so on. So here's our first parent graph. The absolute value of x looks like a V going through the origin, slope of negative 1 on the left, positive 1 on the right. Number two, the cube root of x. It's not x cubed. I saw a lot of people in class graph this one instead. Remember, whatever x value goes in, we take the third root of. So let's pick a good third root. Well, the third root of 0 is 0. And 1, the cube root of 1 is 1. These next numbers don't have a perfect cube until we get to 8. The cube root of 8 is 2. So these are the points we got to keep track of as we are shifting and reflecting our graph. And we also have some values here in the negative quadrants. The cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2. So here's our basic cubic graph. Again, we will be shifting and reflecting this one around. All right, let the fun begin. Here is the absolute value of quantity x plus 3. Now, just to compare, what if we had the absolute value of x and then plus 3? Well, this would be a shift up or down. Up, down is outside the absolute value bars. But we are inside the bars, so this is going to be a shift left or right. And this is the one that's kind of counterintuitive. When I see this plus, plus you'd think you'd move over here to the positive 3. But this we want to think in the reverse. So we want to go to the left 3 units. And from here, the graph remains the same. We are going to have a negative 1 slope over this way and a positive 1 slope this way. I'm definitely going to be looking, you should be going through the y-axis at 3. And up and away. There we go. So we shifted our basic graph 3 units to the left from the plus 3. Now here is our basic cube root function, and we have a plus 4 on the outside of the radical. Again, just to compare and contrast, if this was the cube root of the quantity x plus 4, I would take the cubic graph we did on the second slide, and I would move it 4 this way. So it would look a little something like this. And then we'd have this going over into the other quadrant. But that's not what this problem was asking about. This one was the cube root of x quantity and then plus 4. So this plus 4 is a shift up 4 units. So instead of going through the origin, that point's been shifted up 4 units. We also had a point here at 1, 1. That's been shifted up 4 units, as did this point here. And then we had some points over here in the fourth quadrant that got shifted up into the second quadrant. So there's our shifted graph. Our cube root of x moved up 4 units. Now here's sort of a twofer. The first thing I see here is my absolute value of x. So if I want to think, okay, I got my basic absolute value function would be right here. The negative outside the bars is going to flip us over the x-axis. So now this graph above is going to be shifted to quadrants 3 and 4. So the first thing, that negative outside the absolute value of x turned our graph upside down. Now we have plus 3. Now it's going to shift our graph up 3 units. So this point here, our vertex got shifted up 3, and we go away here with a slope of negative 1. And definitely going to be going through this point 3 on the positive part of the x-axis, and same here, negative 3 on the negative part of the x-axis. And there's our graph, flipped over and shifted up 3 units. Here's another sort of double whammy. The first thing I see, here's our cube root of x. We got a negative under the radical. Here we were outside, so that was a flip over the x-axis. Now here we start number 6 here. Let's refresh our memory on the order in which we do these transformations. Let's see here. Number 1, we do anything vertical. Horizontal. Anything left or right. So horizontal shifting comes first. Number 2, any stretch or shrink. The third thing we do is any reflections over axes. And last but not least, vertical. Up and down shifts come last. Okay, I'm going to switch over to green ink here, make it a little thinner. Our parent function is the cube root of x. So 0 cubed 0, or cube root of 1 is 1. Cube root of 8 is 2. So we're going to look about like this in the first quadrant. Negatives can go in and come out of odd indiced radicals. So we're going to have this also in the fourth quadrant. So let's work our way through here. 1, is there any horizontal movement left or right? Well, right here under the radical, we have this shift of 2. And the minus sign means we're going to shift to the right. So all these key points got shift 2 to the right. So going through the origin is now, shifted over here. And this point got shifted over, and this one got shifted over, and this one also got moved over 2 points to right here. So now we look like this with our first shift, a little horizontal movement 2 to the right. Stretch or shrink, are there any numbers out here? No. So that doesn't work. Reflection over an axis. Yes, we do have one of those. Let me get that original parent graph out of the way. So we do have a sign change under the radical with the x. That's going to be a shift, or excuse me, a reflection over the y-axis. So all the points that were over here are going to get flipped over the y-axis. Let me switch over to blue. So this point here that was at positive 2 is now at negative 2. This point was over 3, up 1. Now it's going to be over here, negative 1, negative 1. It got shifted across. Ooh, no, excuse me. This one was 3 away from the y-axis, so it's going to be 3 away from the y-axis here. This one was 1 away from the y-axis, so here again, 1 from the y-axis. And let's see, this point over here, it was 6 units away from the y-axis. Now it's over here, 6 units away from the y-axis. So we can start to see our shape. We're going to go up this way and come down around here. Again, everything got flipped over the y-axis. And let's see, is that our final answer? That was vertical. Any movement up or down? No. If there was, it'd be a number out here, like +3 would move that whole thing up 3 units. So there's our final graph, the one in blue. All right, here's some stretching and shrinking. We have our function f of x. If I put a number out here, that number you multiply your y values by. If I plug a number in here with the x inside the function, that means we divide our x values by that number. So again, here we have our parent graph. And let me just put a couple points that I can use to illustrate what's going on here. This point up here is 8, 8. And this point over here is -8, 8. Well, let's see, this half is outside the function, so that means we're going to be messing with our y values. And when we're playing with the y values, we multiply. So we're going to multiply the y values times a half, or we're going to cut our y values in half. So this point, 8, -8, well, I'm going to chop that y value to half. So it's going to be 8, 4. So that point is now right here. And same here, chop this y value in half. X value stays the same. It's still going to be -8, but now we only go up to +4. Again, the red graph, ooh, that's pretty bad. The red graph is the parent graph, the original graph. And the black graph is our shifted graph, our shrunk graph. That 1/2 shrunk our y values. Final problem, now in here, we have a number in there in the absolute value bars with the x. So this is going to be, we're going to mess with our x values. And remember, we divide here. We're going to divide x values by 2. So again, I'll switch back to red. Here's the original parent graph. And now we're messing with our y values. We're going to divide our y values, or excuse me, our x values by 2. So at this point, I'm going to divide this x value by 2 and leave the y value alone. So now it's going to be 4, 8 over 4 up 8. And this point over here was -8, 8. Again, I'm going to divide my x by 2. So now it's -4, 8. And there we go. Again, we have messed around with our x values. We had our number in there with the x inside the function, so we divide our x's by that number. All right, good luck on the test.